So let's get started with subject matter today. One person asked the following. He says, Bill, do you have any videos explaining what object light must be? Light exists, so it must have shape. I'm here wondering, what's its shape? More or less. What is the shape of light itself? The rope? And it is a valid question, for hundreds of years. In fact, I think forever, there's been no other alternative other than particles. A series of particles. That's what everybody always thought that light is. That it's mediated by a series of particles. That's the way it's always been treated. In the 17th century, we had, for the first time, Robert Hooke. He came up and suggested that light could be some sort of wave because he saw it through the microscope, one of these old microscopes of those days, and he saw some fringes there, and so he figured out that maybe, just maybe, light moves in wave patterns. On the other hand, his nemesis, Isaac Newton, he believed that light always travels in a straight line. So it was the waves versus the straight line. But they all believed in the ether and mediated with the ether, and the ether was a bunch of particles. And they thought that that's what light was. And to this day, nothing has changed. They always simulate light as a series of particles, okay? Row of particles traveling all what they call in a straight line, meaning rectilinearly. Is that what light is? A bunch of particles, photons, little round balls, I guess, traveling rectilinearly, one right after another, in a straight line, as they say. Well, it's very hard to believe that because, the sun twirls. Every atom in there vibrates and moves around, also spins, as they say. And so, the atom creates light. It sends the first photon, and then it immediately moves, rotates, spins. Sends another one, spins, sends another one, spins, spins, and sends in between. That series of photons can never travel in a straight line. It can only travel in curved lines. It's like a water sprinkler. The first drop goes here, the next one goes right behind it to the side, the other one to the side, the other one to the side, and it describes a curve in space. And so if light were mediated by a series of particles, you would have curved light. We all see it in curves, okay? So no, light cannot be mediated by so-called photons, and particles cannot travel. A series of particles coming out of a source that's moving cannot travel ever. Impossible to travel in a straight line. Then the other issue is, what are the particles somehow connected to each other, so one is pulling on the other in a straight line? Is that how light works? Are they all connected? And so these are valid questions for the structure, the architecture of whatever mediates light. So he asked, what is the mediator of light, essentially? Okay, and so here's what the establishment proposes. They propose that light is some sort of wave. This comes primarily from Maxwell and other researchers of the 19th century who eventually figured out that light is some sort of wave, and they said, well, it's a transverse wave. It's a pair of fields, electric and magnetic fields. Names are irrelevant, but they're fields traveling at 90 degrees to each other. That's more or less how they visualize it. And here's the picture of it. I think you've seen it before. You see up on the top the wave, and at the bottom what we propose. And let's go through this, okay? Let me remove this. So let's go through this, find out what it's all about, okay? So here we have the transverse wave, okay? And what are you staring at? Well, you're staring at a bunch of vectors. That's what you're staring at. The electromagnetic wave that they use out there is so-called transverse, meaning that it travels perpendicular to the motion of those arrows. Arrows go up and down, and the wave travels forward towards your right. And that's known as a transverse wave. As you can see, this is also a two-dimensional wave. That's the notion that we have in front of us. That's what they're illustrating, okay? And so what's the problem? The problem is those arrows are not engine arrows, solid arrows that kill people. Those arrows are actually vectors. Okay, it's known as magnetic and electric field, and what they are made of are these vectors. Okay, here you see them. Okay, those are the vectors that make them. Okay, and so you have the electric field traveling at 90 degrees to the magnetic field, and both of them travel, and the whole wave travels forward. Okay, but each of those fields, which is a mathematical concept actually, is made out of vectors, which is another mathematical concept. Vector only has magnitude and direction. Okay, so when you look at this, what you're looking at, or what you're staring at, is not a physical object. What you're staring at is a mathematical concept which they put in motion. Okay, and so this so-called thing goes one way towards the right in this example. Okay, so it's moving towards the right, and it's made out of vectors, and the vectors make up the magnetic and electric fields. So we have a problem because this is not a physical object. You cannot say that a wave is a mediator for light. Okay, and it turns out that the wave itself is made out of particles. Okay, so we have these waves, and they're made out of particles. They're saying the particles are the ones that are vibrating. Okay, and the question is, if a particle is vibrating, what pulls it up and down or sideways? Okay, something has to take it east-west or north-south. Otherwise, why would the particle return back down again? Okay, so neither particles nor waves can tell you what light is. Okay. The other problem is that this is a transverse wave, and it turns out that transverse waves are the slowest type of waves imaginable. Here you have an example, longitudinal waves. Some like sound, for example, that's a longitudinal wave. It moves back and forth, whereas the transverse wave moves up and down perpendicular to the direction of travel. And so we have a problem here because if you look at the seismic waves during an earthquake, the longitudinal waves, the seismic waves, right, travel 1.7 times faster than transverse S waves, okay, the shear waves. And so we have a problem here because if light were a transverse wave, then longitudinal waves such as sound would travel faster than light. You would hear the thunder before you see the light of the flash of the of the lightning. And so we have a problem here because what these people are saying is that in other words, they've chosen the slowest wave possible, imaginable, to simulate light, and that's where the problem is. Okay, so we have all these problems with the transverse wave. Here it is again. Let me put it back up here. Okay. And so we have all these problems with it. First, it's a bunch of vectors. Those are concepts. They're mathematical concepts. Field is a concept as well, mathematical concept, just a bunch of numbers. Okay. And it travels one way, but what's traveling is not an object. It's not a thing. What you're staring at is an abstract mathematical concept, which they set in motion. Very scary stuff. Okay. And so what do we replace that with? Well, we're going to put something else. We're going to say it's something that looks very much like it, but it's a rope. You can see they both have the same undulation or structural undulation, right? In other words, both a rope and a transverse wave, they really look quite a bit alike. If you were like to, look at them casually, you would say, hey, it looks like the same thing. And you can see why, the electric field runs perpendicular to the magnetic field because one is perpendicular to the other in a rope. Okay? But the rope is a little different in many respects. One of them is that it's made out of an electric thread and a magnetic thread. And again, magnetic and electric, just to keep with convention, those names, right? It's threads, two threads that are twined around each other, instead of fields that are wound up around each other or whatever mathematicians propose. So we're talking about a thread. Thread is an object. Field is a concept. So these are two different things. We're not just naming things. We're saying that the field of mathematics is a bunch of vectors, which are all mathematical concepts. You cannot say that a concept moves or that can serve as a mediator for light. On the other hand, thread is a physical object. And if you don't believe me, ask your grandmother for her sewing thread, and you'll find out what a thread is. Okay? It's a little string, a little wire, whatever you want to call it, an elongated entity. Okay? And so, yeah, we have this proposal there. Okay? And what's the issue? The issue is that this rope, as we call it, these two twined threads, they torque. And a torsion wave is the fastest type of wave imaginable. In fact, it's the fastest thing known to man. Let me repeat that because maybe it didn't sink in. The fastest thing you can imagine is a torsion wave. There's nothing faster than that. Not a rocket, not not a ship, not a car. I don't care what you put in there. There's nothing faster than a torsion wave. What is a torsion wave? And again, we use the word wave. You know what it is really an in situ torsion of the rope. That's why it's so fast, because it doesn't go anywhere. It just torques in place, and what moves or what propagates, you could say, along the rope is this motion, this signal, right? You could call it. Nothing is really propagating. What's happening is at the ends of the rope, it's thumping against the two atoms on opposite ends. Because one of the things about this rope is that it's bidirectional. Okay? The rope travels, you could say travel, even though the word travel is incorrect, the rope goes nowhere. But what happens by torquing, it thumps against the two atoms that are at opposite ends. And that's what we call light. This torsion that gives a little push, you could say, a little torsion right at the edge of the atom, at the edge of the what we call the electron shell. In fact, the rope makes up the atom itself. And so it's giving this thump to the atom, and the atom is on the same time it's vibrating and sending signals through this rope as well. It's torquing it. The vibration of the atoms is torquing the rope. And so now we can see why this is a better mediator or proponent as a mediator for light. Because first, it's a physical entity. It's bidirectional. It goes from the atom in your eye to my eye and vice versa. And also simultaneously, okay? And it's torsion, which is a faster wave than either transverse or the longitudinal wave. And it's fast because it goes nowhere. Okay, that's essentially the summary for that. But here you see it. Why? Einstein, among others, believed or came to the conclusion, right, that light travels always at a constant speed. There you have the speed of light, little c, which is 300,000 kilometers per second. And what is it equal to? It's equal to frequency times wavelength. That's what the little f and the lambda there stand for. Frequency and wavelength. Meaning, if you raise the frequency, you must lower the wavelength for little c to be constant, and vice versa. You raise the wavelength, the frequency must drop. And the only entity in the universe, the only entity imaginable that can simulate this is a rope. Okay? As you can see on the right, if you torque a rope more and more, you will get more links, and each link will be shorter. And if you untorque it, well, you get the reverse. You get the links are longer, and you'll have fewer links for any given length of rope. So we do have an explanation, not only for the speed of light, we have an explanation for why it's bidirectional instead of one way, like the transverse wave or the photons of quantum mechanics. We have this right shape. It's an undulatory shape. It's a structural issue there. Okay. What else can we look at? You also have one thing I haven't touched upon is the amplitude. Okay, so you do have amplitude in the wave. It's got all these features that a wave is supposed that light is supposed to have. And so, yeah, this is what we essentially simulate light with. Here you have the dynamic version of that. Okay, that's more or less what we're proposing. We're saying that whereas the wave, the transverse wave, travels in a single direction and has all these vectors, which are mathematical concepts, these fields, which are mathematical concepts. We're just talking about magnitudes, values, units. That's all we're talking about there. And you compare it against the rope, which not only explains the speed of light, but it has the right structure and it's bidirectional. Okay, and so we think it's a much better candidate for light than what we have today. And I'm talking about both the transverse wave as well as the photons, a series of little particles, which is actually what they really simulate it with. If you go to the standard model of quantum mechanics, you won't find any waves. What you will find is the photon. What is a photon? A particle. It's called particle, the standard model of particles. Quantum mechanics is a particle theory, corpuscle, you know. But it's not a corpuscle because, again, they say that the particle is not a particle. Particle is a number. That's what they accelerate at the CERN and SLAC and Fermilab. All these people accelerate numbers, okay, values. When they talk about energy, they're not talking about a little gas or anything like that. They're talking about particles, okay? I'm sorry, they're talking about number. Particles, yeah, but the particle is the number, okay? It's just the value that they have, and they play around with the values. That's how they can transform energy into mass, mass into energy. They play around with charge, and all these words are mathematical words, and all they have to do with are values, magnitudes, amounts. That's it. That's all they can put in an equation. They cannot put the word rope in an equation. They cannot even put the word wave or the word photon in there. Okay? No, they have to put a number, the value. So keep that in mind when you make up your own mind on whether, you know, what could be the mediator of light. And yes, there had better be a mediator of light, because during the photoelectric effect, what you have is, this is at least the interpretation, right? That you have a photon, little ball, that hits the electron ball, right? And compels it to move to another atom, and the flow of all these electrons from atom to atom, that's what electricity is. And that's what a photoelectric effect is. You have a beam of light shining on polished metal, and a current flows. And what's that current? A bunch of electrons moving from atom to atom. What triggered it? The photons that hit it. Okay? And so they have a series of particles hitting a bunch of particles known as electrons, which start to move. Okay? So the photon had better be something if it can move an electron, which is alleged to be a part of our 3D world. Okay? So that's the story.